In this video, we're going to evaluate the integral of 2x over x squared plus x plus 1. Now, my favorite method of integration, if applicable, is a U substitution. Notice in this integral, if I take the derivative of the numerator or the denominator, I get 2x plus 1. Well, I got the 2x already there. Partial fractions won't do it here. So what I'm going to do, remember you can always add 0 and not change the problem. So here what I'm going to do is add 1. And subtract 1. 2x plus 1 minus 1 is still the same integral. And then I'm going to break this up into two integrals. The first one will be 2x plus 1 over x squared plus x plus 1. Integration with respect to x here. And then the other one will be a minus. I'll put the minus out of here. That'll be minus the integral of 1. I'll put the dx up here over that same denominator. Now for the first one, it's going to be a regular substitution here the way I set it up. So I'll let u equal to x squared plus x plus 1. Then du would be the derivative of what we have in the right there. That'll be a 2x plus 1. Put this in parentheses, and then that's multiplied by dx. So notice over here in the numerator, you got dx plus 1 dx. That's going to be your du. And of course, the x squared plus x plus 1 is going to be the u. So this one's going to be a simple integration with respect to u. So it's the integral of du over u. Now for the second integral, I'm going to complete the square. X squared plus x plus 1. And the 1 here, notice if I take, since the coefficient of the square term here is 1, to complete the square here, I take 1/2 the coefficient of the x, which is 1. So it'd be half of that is 1/2. Square it, I get 1/4. So in order to complete the square on this right here, I have to have a 1/4 here. So I can add 1/4 and subtract 1/4. That's adding 0. Or I could just break up the 1 and say 1 is the same thing as 1/4 plus 3 over 4. 3 over 4 and 1/4 is 1, so I haven't changed it. And then this part right here then, this trinomial here, can be written as x plus 1/2 quantity squared. And then this could be plus 3 over 4. That's the same thing. And then the formula I'm going to use for the second integral is going to be this one here that we used before. It tells me if I have the integral of something of the form du over u squared. So anything in this form, integral of du over u squared plus a squared, where u can be a function of x and the a is going to be a constant. The formula tells you that the integral of anything in this form is going to be 1 over a. And then it's arctangent, or you can write tangent inverse. So the formula tells you have the integral of du over u squared plus a squared. That will equal to 1 over a, whatever the a is, but that's a squared. 1 over a tangent inverse of whatever u is over a plus the constant of integration. So here's the situation then. This is going to go here. So just to save me some time here, we got the integral of dx over 1 plus 1/2 quantity squared plus 3/4. And then for this to fit the formula then, I'll write this as square root of 3 over 2 squared. So the square root of 3 over 2 squared, just another way of writing 3 over 4. And I'm doing that so it fits this formula here. So in our case, for this formula, the u is going to be x plus 1/2. Notice if I set that equal to u, du will be 1. So I can just leave it as is and proceed with the integration. So let's do this one right here. This one will go here. So this will be natural log, and it'll be absolute u. But this x squared plus x plus 1 is never going to be negative. You can test it out, but if you were to sketch a graph of this, it's a parabola that stays above the x-axis. So I don't need absolute values. I'm just going to put parentheses. Now, if you write absolute values, it's not wrong, but we don't need them in this case because this is not negative. So the integral in this form is natural log of, you can say absolute u or just u, and u we know is x squared plus x plus 1. So that takes care of that. And then it's minus, for the second integral, remember in the denominator we have x plus 1 squared plus, and it's the square root of 3 over 2. So in that case, for the formula, this is going to be your u right there. And the a, this is considered a squared here, which is the square root of 3 over 2 squared. So a is the square root of 3 over 2. So the formula states that this is going to be tangent inverse of u, which is x plus 1/2. So for the first integral, it's natural log of x squared plus x plus 1. Remember, this is 1 over a here. And in our case, a is the square root of 3 over 2. So that'll be 1 over that. So that that would make this a 2. So that's a minus 2 over the square root of 3. That corresponds to this 1 over a in the formula. In our case, a is the square root of 3 over 2. So if I reciprocate that, that would give me that. And then on this part right here, inside the parentheses, if I just multiply through by 2, numerator and denominator, this 2 would cancel in the denominator. This will become a 2x. And then 2 times the 1/2 would give me a 1. And we could rationalize this right here, make this the square 2 minus 2 square root of 3 over 3. And the same thing here in this parentheses. We'll leave it like this. And the answer then is natural log of x squared plus x plus 1 minus 2 over the square root of 3 tangent inverse, or you can say arctangent of, and this quantity in the parentheses then is going to be 2x plus 1 over the square root of 3. Thanks for watching. We'll see you next time.